The spiral is known as the Fibonacci spiral due to its origin from the Fibonacci sequence. The Fibonacci sequence is the following sequence: 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and 55, obtained by adding the previous two terms. The spiral is very similar to the golden ratio spiral found in nature, which is sometimes referred to as the ratio of beauty. The Fibonacci method is a constituent of patterns and numbers. The Fibonacci method refers to a mathematical process or algorithm used to generate the Fibonacci sequence, a series of numbers where each number is the sum of the two preceding ones, starting with 0 and 1. The sequence begins at 0, 1, 1, 2, 3, 5, 8, 13, and so on. Various ways to solve Fibonacci method. You could either use arithmetic, recursive, or the Binet's formula. Now, let's solve these following questions using the Fibonacci method. To solve the next term of the given numbers, we will be using the arithmetic formula. First, let's write the formula we are going to use. Where the value of a is 1. Now that we have written the formula, let's now substitute the given numbers. A1 will be the first term in our given numbers. Now to get the next number, we will add the previous number to its difference. 4 minus 1 equals 3, therefore we add 3. Same procedure applies to the next number. A3 is equal to 4, which is the previous number, is added to its difference, which is 5, equals 9. Then the third term would be 9. Now repeat the procedure to get the fourth term. Fourth term equals 9, the previous number, plus its difference, 7, equals 16. Therefore, the fourth term is 16. Same procedure is applied to the following numbers. To get the difference of each number, just subtract the current term to its preceding term. Now let's solve the next number, which is the 8th term, using the arithmetic formula. To solve for the 8th term, we will now substitute the 7th term to the formula, which is 49. Just follow the arithmetic formula to not get confused. Now we put 9, which is the 7th term or the current term, plus, open in parenthesis, 2. 2 is a fixed number in the arithmetic formula. Now we multiply it to the next term or the term that we are looking for, which is the 8th term. 8th term, then minus 1, then close parenthesis. After substituting the given numbers, let us now solve what is enclosed in the parenthesis and add it towards 9. 2 times 8 is 16, minus 1 is 15, therefore we add 15. For the last step, we add the remaining numbers. Now 49 plus 15 is equal 64. Therefore, the 8th term or the next term is 64. See, solving Fibonacci method is as easy as a pie, especially that it is bounded by pattern. Now let's add the 64 at the side of the 7th term and box the final answer. Now this is the summary of the procedure that we just did. The first step is to look for the first term, then the second term, then the third term, then add the current term to its difference to get the next term. However, solving Fibonacci method is time-consuming if you go through all that process. A much easier and convenient step is to use the arithmetic formula and substitute the given numbers to get the final answer. For the next question, let us now solve the missing number or the fourth term. As what you can observe, the difference is already obvious. Therefore, we will write the arithmetic formula this way. AN equals AN plus DN. DN will be the difference and we will add the value of DN to each number. The value of DN will be 2. To make it easier, let's write down the difference. Then add the difference to the next term to get the next difference and so on. Now that we have wrote the difference, let us now write the formula we are going to use. A for the fourth term equals the third term. Then we will add the third term to the fourth difference. After writing the formula, substitute the given numbers. The third term will be 9 and the fourth difference will be 6. Then add the given numbers, which is 9 plus 6 is equal 15. Therefore, the fourth term is 15. Fifteen will be the final answer. To compute the missing number in the sequence, observe first the given sequence, and when you finally see the pattern in its differences, we can observe that in each number the differences is increased by 2. Following the procedure we did earlier, write the formula, substitute the given numbers, then solve for the next term. Hence, this formula is applied to those terms which differences increases. Now let's find the next three terms of the given numbers. Now to compute the next three terms, we will apply the same procedure we did in the first question. So first term minus second term is equal -1. Second term minus third term equals -2. Third term minus fourth term equals -2. And fourth term minus fifth term equals -5. Therefore, -5 is the sixth term. Now, to not complicate things, repeat the procedure on the next three terms. Subtract -5 to 6. As what we could observe in the first term and second term, they are bounded by 1 difference. Now, subtract the seventh term to -7 equals 18. Now that we have the full answer, here we go. We have the answer for the next three terms. The next three terms of the sequence 10, 9, 7, 4, and 0 is -5, -11, and -18. And we solve it in arithmetic way. And for the last number, we compute what is the fourth term of the given sequence with the arithmetic formula written above as the value of d is 4. To solve for the fourth term, we add the third term towards the value of d. Now substitute the third term and the value of d. Now we add the two numbers. -2 plus 4 is equal +2. Therefore, the fourth term or the missing term is 2. Here is the summary of the procedure we have done. This is another example. What is the nature of the number 88, 77, 55, and 22? As what you could observe in these numbers, they share a common characteristic, which is all of these numbers are divisible by 11. This makes them notable for both their palindromic structure and their relationship to the number 11. A palindrome is a number that reads the same forward and backward. These numbers have a perfect symmetry, which makes them aesthetically and numerically interesting. Hence, the number, palindromic nature, and divisibility by 11 are not coincidental. This connection arises because the palindromic numbers with two identical digits are always divisible by 11. This is due to the mathematical property of 11. When checking divisibility, the alternating sum and difference of the digits of a number must be divisible by 11. For our last example, how are each terms related to one another in the sequence 2, 90, 4, 87, 6, 12, 8, 51, and 10. The sequence alternates between two patterns. The even index numbers 2, 4, 6, 8, 10 increase by 2 each time, while the odd index numbers 90, 87, 12, and 51 change in an unpredictable way, first decreasing then increasing.
Thank you for watching.